Hey, welcome to Trixar. Today we'll be talking about L'Hopital's rule. L'Hopital's rule is something you can use to evaluate limits in certain scenarios. The rule is the following. Let's say you have to evaluate the limit at x is approaching a of a function that follows the form f of x over g of x. If this is equal to an indeterminate form, then the limit of x approaching a of f of x over g of x is equal to the limit of x approaching a of f prime of x over g prime of x, only if the limit of x approaching a of f of x over g of x is indeterminate. So what is something that's indeterminate? Well, it usually follows the form 0 over 0, or it could be infinity over infinity. Anything like this is indeterminate. And if your limit of x approaching a of f of x over g of x is equal to an indeterminate form, then that limit is also equal to the limit of x approaching a of f prime over g prime of x. And you can repeat this step any amount of times. For example, if the limit of x approaching a of f prime of x over g prime of x, if that's also equal to an indeterminate form, you can also find the second power derivative, and you can derive it again as many times as you need to do, as long as it's equal to an indeterminate form. Let's work through a couple of practice problems. To start off, we have the question, the limit of x approaching infinity of x squared over e to the x power. If we try to solve this by plugging in x as infinity, we end up with the answer infinity over infinity, which is indeterminate, which means we can apply L'Hopital's rule. Applying L'Hopital's rule, we can rewrite the limit as the limit of x approaching infinity of 2x over e to the x power. But again, if we plug in x as infinity, we end up with the answer infinity over infinity, which is once again indeterminate, which means we can apply L'Hopital's rule again. So we can rewrite the limit as the limit of x approaching infinity of 2 over e to the x power. This time, if we plug in x as infinity, we can end up with our final answer of 0. Let's move on to our second example. We have the limit of x approaching 0 of sine of 7x over sine of 4x. So how can we solve this? Well, if we plug in x as 0, we end up with the answer 0 over 0, which is indeterminate, which means we can apply L'Hopital's rule. Deriving the top and the bottom of the fraction, we can rewrite our limit as the limit of x approaching 0 of 7 cosine of 7x over 4 cosine of 4x. If we plug in x as 0, we end up with our final answer of 7 over 4. Moving on to our last question, we have the limit of x approaching infinity of ln of x over x. Well, if we plug in x as infinity, we get the answer infinity over infinity, which we know to be indeterminate. So let's apply L'Hopital's rule, and let's derive the top and the bottom of the fraction. So we can rewrite our limit as the limit of x approaching infinity of 1 over x over 1, which is equal to the limit of x approaching infinity of 1 over x, which gives us a final answer of 0. So these are three questions that use L'Hopital's rule. Thank you for watching. If you have any questions or any other calculus concepts you'd like me to discuss, just leave a comment down below. Thank you for watching, and as always, please make sure to subscribe.